Hey Valley Metal, welcome back to another G67 math video. Tonight we're going to be using a scale factor to find the area and perimeter of similar shapes. But let's start off with our trivia question. Who is this guy? And I'll even give you his name, Chip Wilson. But who is this guy? We'll be back to the answer to that after instruction. Tonight officially our target is I can use scale factor to find the perimeter and area of similar shapes. Let's do this thing. Let's study these two shapes here. We have these two rectangles and they are similar. This original rectangle here has an area of 8 and a perimeter of 12. Now, this one here is twice as large. It has a scale factor of 2. And if you take a look at the measurement of the perimeters, you're going to notice something. The original perimeter of this rectangle was 12. The perimeter of the rectangle that is twice as big is 24. You'll notice that the perimeter doubled. Scale factor was 2, the perimeter doubled. You'll notice that the area of the original was 8. You'll notice that the area of the new one is 32. But before I click and show the red lines, look at it's exactly 4 times as large. Because when the sides lengths double, it doubles this way and this way. So it's going to be, the area is 4 times as large. And I think I can get those 32 units in there as well. All right, let's look how we could find, given this rectangle and a scale factor, how we could find the area and perimeter of this new one if these numbers weren't here. All right, here's the way it works. You take the original perimeter of this one, which is 12, and you multiply it by the scale factor of 2. You get the new perimeter, 24 centimeters. You can take the original area, 8, and multiply it by the square of the scale factor. So the scale factor was 2 squared. So then I'm going to simplify in this next steps. 8 times 4, I have 32 centimeters squared. Interesting, huh? So we wouldn't even need these measurements if we knew, the perimeter and the area, or if we could determine the perimeter and area of the first rectangle and we knew what the scale factor was. We wouldn't even need to draw it. We could just say, hey, the area is 32. It's got a perimeter of 24. All right, let's take a look at some of the must-know words for tonight. First of all, similar figures. These are two geometric shapes with corresponding angles that are equal and corresponding sides that are proportional. We've been over these things. Scale factor, that's that ratio of corresponding sides in similar figures. The perimeter, that's the distance around the outside of the shape. And the area, of course, is the number of square units that can be contained within a shape. Let's go backwards. Before we went from a small to a large, let's take a look at a very simple sample. We're going from a larger shape down to a smaller shape. It's a reduction. So in our original square, it was 3 by 3, or 3 units by 3 units. Therefore, the perimeter is 12 and the area is 9. And you can see I've already put the area and perimeter in on the smaller one. But the scale factor of this is 1/3. This one is, everything is 1/3 the size. Therefore, the sides, instead of being 3, are 1. All right? So let's take a look at how this works mathematically using this little formula I'm teaching you. You take the original perimeter, which is 12, you multiply it times the scale factor. It went from 12 down to 1/3 of that. Well, 12 times 1 is 12. When you divide that by 3, your new perimeter is 4, which is what it is. Do the same thing with the area. We can take that original area times the scale factor squared. So we had 1/3 squared. Let's simplify that to 1/9. So now you've got the original area of 9 times that 1/9. Well, 9 times 1 is 9. Divided by 9 is 1 unit squared. So we were able to determine it mathematically as well. All right, quick review. When finding scale factor, here are two similar shapes. All we need is one side that is in the same corresponding area in order to determine that. So on this pentagon, we're going to use this side, which is 6 inches, and the corresponding side on the larger one is 18 inches. So we can just build a little ratio proportion box. We have the small is 16, the large is 18. I just put 1 down there because I want to find out what the scale factor is. It's like a unit rate. 1 times 18 is 18 divided by 6. We'll see that we have a scale factor here of 1 to 3. Looking at this one up here, it's 3 to 1 because we're going from the larger to the smaller. But if we're going from the smaller to the larger, it's 1/3. Okay, so this one is 1/3 the size, this is 3 times the size. And you'll notice that those are reciprocals, 3/1 and 1/3. We had this in the last night's lesson. All right, let's move forward some real life examples here. Let's say you want to put this football field, a regular NFL-sized football field in your backyard, and you know you do not have 360 feet by 160 feet to build this. So you figure you want to see if you can do it by exactly half the size using a scale factor of 1/2. So what would we do here? Well, the first thing we need to do is determine, the perimeter and the area of the original one. So we have 160 feet by 320 feet. So if we add up all those numbers, 360, 360, 160, and 160 for our perimeter, we get 1,040 feet. We can determine the area by multiplying these two together, just like a rectangle, and it is 360 times 160, which is 57,600 feet squared. So now we're going to use those measurements to determine the perimeter and the area of the smaller one. All right, we'll apply scale factor. We take that original perimeter of 10,000 or 1,040, we multiply it by the scale factor of 1/2, and we get 520 feet as our new perimeter. Makes sense. This one is twice as big. The perimeter on the smaller one will be half of that. Well, how about the area? Well, the original area was 57,600 feet. If we multiply that times the scale factor squared, let's simplify 1/2 squared real quickly. 1/2 squared is 1/4. So if you take that original area, 57,600 feet, times 1/4, your new area would be 14,400 feet. And it's beautiful. Oh, I can click up here. I think I probably have those measurements in here someplace. Where are they? Here they are. So the new dimensions you could figure out too, if you halved them. If you took half of this side, it would be 80. If you took half of the 360, it'd be 180. And you could multiply those together to check your work if you want. But you also can determine the area and the perimeter just by using scale factor. All right, time for you to try one. Go ahead and try this pizza. We have a scale factor of 3 between the larger one and the smaller one. And this is side is 6 inches and 3 inches. Go ahead, give it a shot. All right, first thing you had to do is determine that perimeter. Well, the perimeter of the smaller one is 18 inches. 3 and 3, 6 and 6 is 18. And the area of the smaller one, of course, is 18 inches squared. So, applying those things here, let's just double check, see how this worked out. The original perimeter was 18. We take that times a scale factor of 3. We have 54 inches. That totally makes sense too. Look at, I could stack these guys right in here. All right, just a couple more seconds. It's coming soon. And we could determine our perimeter there. So we're going to have 18 on this side, and we're going to have 9 on this side. And if we double those, add them all up, you'd have 54 inches as your new perimeter. Well, the original area was 18. And we're going to take that times the scale factor squared. So I'll simplify that scale factor. So now we have 18 times 9, which gives us 162 inches. And once again, you can see that how that comes about because we've got 9 inches over on this side multiplied by 18 inches. We did it mathematically without having to draw it out using the scale factor. Nice work. All right. Yeah, but would it possibly work with wheels or with circles? Well, let's think about it. We've got this wheel here with a 24-inch diameter. And we've got a scale factor of 2 on this one. So let's just go ahead and figure out what the perimeter, which we call the circumference when we deal with it when it's a circle, and what the area is. So the perimeter or the circumference of this wheel, you take an abbreviation of 3.14 times the diameter, pi d, gives us 75.36 inches. The area of it would be 3.14 times 12 times 12, or pi r, or pi r squared, which would give us 452.16 inches squared for the area and the circumference of the smaller one. So using the scale factor, we should be able to find the diameter, we should be able to find the area and the circumference of this larger wheel. So let's go ahead and do it. So the original circumference was 75.36. If we take that times the scale factor of 2, the new circumference would be 150.72 inches. All right, how about the area? We'll take the original area of 452.16. We're going to multiply that times the scale factor squared. So let's simplify that. I'm just going to shut this dude down. That's 452.16 times 4, 2 squared, is 1,808.64 inches squared. Okay? And obviously, if we're using a scale factor of 2, if the diameter of this one is 24, the diameter of this other one, I thought I had it there, I guess I don't, would be 48. Okay? All right, let's keep rolling. Time for you to try one. Now, I did a circle. You should be able to go and find the size of this smaller pennant, given all the measurements here of this Vikings pennant on the large one, in a scale factor of 1/5. Find the perimeter and area of this smaller pennant. Go ahead and pause the video. Okay, let's see how you did. Well, first you would have had to determine the perimeter and area of this larger one. So we added up 110, 110, and 40, our three sides. We had 260 centimeters as our perimeter. The area was base times height divided by 2, so that's 40 times 100. Then we divide that by 2, we have 2,000 centimeters squared on the larger one. So let's use that and see if you were able to determine the perimeter and area of the smaller one using the scale factor. So the original perimeter was 260. We multiply that times 1/5. You can put that into the calculator as 0.2 if you want, and you get 52 centimeters, which is correct. The original area was 2,000 times that scale factor, 1/5 squared. Well, 1/5 squared is really 1/25, so 2,000 times 1/25 gives us 80 centimeters squared. So, if you got that, you did pretty well. I threw in these new dimensions here. You know, we could just divide these sides by 5, 2, 40 divided by 5 would be 8. 110 divided by 5 would be 22, and the new height would be 20 centimeters. Cool. All right, you're ready for the ticket to the show. One problem tonight. Use the scale factor to find the perimeter and area of the larger shape. The smaller shape is 2 centimeters by 1 centimeter, and the scale factor is 4. All righty. All right. Who is Chip Wilson? Who is this guy? Well, how about this? Would this help you? No. Boys, probably not. Maybe the girls. How about this? Yes, he's the billionaire owner of Lululemon Athletica. All right. Why couldn't I have come up with that and made all that money? I wouldn't be making cool math videos, though. All right. Thanks a lot for listening. Have a great evening. Bye.